is a fundamental aspect of building design and construction. It not only supports the structure but also contributes to the functionality and appearance of the building. Properly designing and placing lintels ensures safety, durability, and consistency throughout the structure. If you're working on a specific building project, I can help you calculate lintel sizes or recommend materials based on local codes. Reinforced cement concrete (RCC) lintel. A reinforced cement concrete (RCC) lintel is a structural horizontal member used in building construction to span openings such as doors, windows, and ventilators. It is made of concrete that is reinforced with steel bars to enhance its tensile strength, making it capable of bearing loads from the structure above the opening. Purpose of RCC lintel. The primary purpose of an RCC lintel is to support loads from the wall above an opening, transfer the load to the adjacent masonry or structural members, prevent cracks or structural failure that may occur if the wall alone bears the load. Components of RCC lintel. Cement concrete, generally a mix of cement, sand, aggregate, and water in a ratio such as 1:2:4, M15 grade, or 1:1.5:3, M20 grade, depending on structural requirements. Reinforcement steel. Steel bars, rebars, are embedded in the concrete to carry tensile stresses. Main bars run longitudinally, while stirrups, links, are provided to resist shear and hold the main bars in place. Design considerations. Span length, typically up to 2.5 meters without additional support. Longer spans may require special design. Depth and width, generally 1/10 to 1/12 th of the span for depth, width equals the wall thickness. Reinforcement, based on loading, main bars are placed at the bottom with stirrups at specified spacing. Cover, concrete cover of about 20 to 25 millimeters is provided to protect steel from corrosion. Advantages of RCC lintel. High strength and durability. Fire and weather resistance. Uniform load distribution. Less deformation compared to wooden or brick lintels. Can be cast in situ or precast, offering flexibility in construction. Applications. RCC lintels are widely used in residential buildings, commercial complexes, industrial structures, infrastructure projects where durability and strength are crucial. Conclusion. RCC lintels are a reliable and commonly used structural component in modern construction due to their strength, durability, and ability to efficiently transfer loads. Proper design and construction practices ensure their effective performance and longevity in a variety of structural applications. A brick lintel is a horizontal structural element made of brick that spans an opening in a wall, such as a window or door. It supports the weight of the wall above the opening and transfers the load to the surrounding masonry. Brick lintels are commonly used in traditional masonry construction and can serve both functional and aesthetic purposes. Types of brick lintels. Plain brick lintel. Constructed using regular bricks laid flat across the opening. Typically used for small openings where the load is relatively low. Reinforced brick lintel. Incorporates steel reinforcement bars within the brickwork. The bars are placed in the mortar joints or in holes drilled into the bricks. This type is suitable for wider spans and higher loads. Brick arch lintel. Although technically an arch, it functions similarly by spanning an opening. It distributes loads more efficiently due to its curved shape. Construction considerations. Material quality. High quality, well-fired bricks and strong mortar are essential for durability. Bonding pattern. Common bonding methods include stretcher bond and header bond for strength and stability. Reinforcement. When using reinforced brick lintels, correct placement and coverage of reinforcement is crucial. Curing. Proper curing of mortar ensures the lintel gains full strength. Advantages. Aesthetic integration. Matches surrounding brickwork seamlessly, preserving architectural harmony. Fire resistance. Brick is inherently fire resistant, making lintels durable in high-temperature situations. Cost-effective, especially where bricks are readily available and labor is skilled in masonry. Limitations. Limited span. Plain brick lintels are only suitable for narrow openings. Larger spans require reinforcement or alternative materials like concrete or steel. Labor-intensive. Requires skilled masonry work for proper construction and alignment. Applications. Brick lintels are commonly used in residential buildings, historic structures, load-bearing masonry walls. In modern construction, brick lintels are often used in combination with concrete or steel lintels hidden behind a brick facade to maintain traditional appearance while meeting structural requirements. Let me know if you need a diagram or comparison with other types of lintels, like steel or RCC. A stone lintel is a horizontal structural element made of stone, used primarily in architecture to span an opening, such as a doorway or window, and to support the weight of the wall above it. It is one of the oldest architectural components, dating back thousands of years and seen in ancient structures across civilizations. Features of a stone lintel. Material. Typically carved from durable stones like limestone, sandstone, granite, or basalt. Shape. Rectangular and elongated, sometimes slightly tapered or decorated depending on the style and era. Function. Transfers the load from the structure above the opening down to the vertical supports or walls on either side. Helps maintain structural integrity by preventing the wall above the opening from collapsing. Historical and architectural importance. Ancient civilizations, stone lintels were widely used in ancient Egyptian, Greek, and Indian architecture. The post and lintel system, vertical posts supporting a horizontal lintel, is fundamental to megalithic architecture, such as Stonehenge. Temples and palaces. In Hindu and Buddhist temples, stone lintels often feature intricate carvings of deities, floral patterns, or mythological scenes. Medieval architecture. In castles and Romanesque churches, stone lintels were used in doorways and windows, often combined with arches for added strength. Advantages. Durability. Resistant to weathering, especially in dry climates. Aesthetic value. Can be ornately carved or left simple to match various architectural styles. Fire resistance. Unlike wooden lintels, stone does not burn, making it ideal for historical buildings. Limitations. Weight. Stone lintels are very heavy, requiring strong support and careful handling. Span limitations. Without reinforcement, stone lintels are limited in how far they can span without cracking. In modern construction, stone lintels are less common due to the prevalence of steel and reinforced concrete, which offer greater flexibility and strength. However, they remain a popular choice in restoration projects, heritage buildings, and for achieving a traditional aesthetic. A steel lintel is a structural horizontal support element made of steel that spans an opening in a wall, such as a door, window, or other aperture. It plays a crucial role in distributing the load from the structure above the opening to the surrounding masonry or wall sections, ensuring structural stability and integrity. Purpose and function. Load-bearing support. The main function of a steel lintel is to bear and transfer loads from above the opening to either side of it. Prevention of wall failure. Without a lintel, the wall above an opening could collapse due to a lack of support. Reinforcement. In combination with brickwork or blockwork, steel lintels help strengthen the wall system. Types of steel lintels. Angle lintels, made from steel angles, usually L-shaped sections, often used in small openings. Box lintels, hollow rectangular sections that provide greater strength and are used for larger spans. T-beam lintels, T-shaped cross-sections that are strong and versatile. Custom fabricated lintels, tailored to unique architectural or structural requirements. Advantages of steel lintels. High strength-to-weight ratio, strong yet relatively light, reducing the load on the foundation. Durability, resistant to warping, shrinking, and rotting, unlike timber lintels. Fire resistance, more fire resistant compared to wood or some other materials. Versatility, can be manufactured in a wide range of shapes and sizes. Ease of installation. Prefabricated steel lintels are relatively easy to install.